In this problem, we're being asked to find the area of a triangle as a function of x, its base. Now, of course, you can tell by the diagram that the longer the base is, the more area this triangle is going to have. And so it makes sense, just on an intuitive level, that the area would depend on x or be a function of x. So in this problem, in some sense, we're thinking of x as a known quantity, but we're also thinking of it as a quantity that we don't specifically know. In other words, we're thinking about it as a variable, but not a variable we're solving for, rather a variable that's just going to appear in the answer. So the first thing that crossed my mind is the area formula of a triangle. The area formula of a triangle is 1/2 times base times the height. And so it would be nice in some sense if I could find the height of this triangle. And when I say find the height, I don't mean find it numerically. I mean find the height as a function of x. Because of course the height will also vary depending on what x is. So I took the area formula here, 1/2 times base times height. Now it's important to note here that even though there are two letters in my area formula, x and h, one of them is in some sense allowed to be there, and one of them isn't. Now it's true that both x and h are variables, and they relate to one another. As x grows, h would probably grow as well. But because of the directions of the problem, look at the top of the screen, because we want the area as a function of x, the assumption implied by these directions is that there should be no other letters in the answer other than x. And that means I've got to somehow get rid of the h using geometry and algebra. Well, in order to get rid of the h, I need to make an equation that has an h in it. And I thought the best way to do that would be to use this right triangle that you see here in red on the left side of the diagram. Just using that right triangle, I can now use SOHCAHTOA to make an equation. Well, I'm not using all of SOHCAHTOA, just the SO part. The fact that the sine of that angle is the opposite side over the hypotenuse for that right triangle. And by setting up this SOHCAHTOA equation, I can cross multiply and actually solve for h numerically, which I didn't anticipate my ability to do. I guess my earlier statement that as x grows, h would also grow is not true. We can see here that h is not a function of x, h is a constant. Anyways, from unit circle knowledge, we know that the sine of 30 is 1/2, and therefore we can work out h to be 4. What does that mean physically? That means that no matter what the base of this triangle is, and it can be very short or very long, the height of this triangle is going to be 4 no matter what. So I can now plug that 4 into the area equation, and multiplying the 1/2 times the 4 tells me that the area of this triangle is 2x. And that completes this problem.